The straight line L passes through the points with coordinates -10, -4 and 5, 4. Part A. Find the equation of line L in the form ax plus by plus c equals 0, where a, b and c are integers. So let's work out the gradient of line L first of all by doing the change in the y coordinates divided by the change in the x coordinates. So the change in the y coordinates, we've got 4 minus -4. The change in the x coordinates, we've got 5 minus -10. So 4 minus -4, so 4 plus 4 is 8. 5 minus -10, so 5 plus 10 is 15. So that's the gradient of line L. And I can now say y equals m x plus c. Now, in order to work out the c, I could substitute either of these points in, because line L goes through both of them. I'm going to choose to substitute the point 5, 4 in, because that way I don't have to worry so much about the negative numbers. Make my life easier. So the y is 4 when the x is 5. The y is 4 when the x is 5. So we get 4 equals, now the 8 over 15 times 5, well, they're going to cancel out and just be 8 over 3. Take the 8 over 3 away from both sides. And 4 minus 8 over 3. Well, to help us with that, let's get a common denominator. So the 4 over 1 is the same thing as 12 over 3. And now I can see that my c value is 4 over 3. So let's plug that back into my equation up here. And just press pause if you need to copy that working out down, because I'm going to rub this off now, just to give myself a bit of room. Because I've got the equation of my line, I just need to write it in the correct form, or at least the form that I've been asked for, which looks like this. So I'm first going to multiply through by 15 to get rid of these fractions. So 15 times y. The 8 over 15 times 15 is just 8, so I get 8x. And then the 4 over 3 times 15 is just like doing 4 times 5, which is 20. Take the 15y away from both sides. And that's my answer to part A of this question. Right, part B. We're told that the line L crosses the coordinate axes at the points P and Q. And then we need to find as an exact fraction the area of the triangle OPQ, where O is the origin. So, in order to work out the area of this triangle OPQ, we need to know what P and Q are. They are where it crosses the coordinate axes, so where it crosses the x-axis and the y-axis. So let's start with the x-axis first of all. So I know it crosses the x-axis when y equals 0. So if I take my equation and make y 0, I've got 8x minus 15 times 0 plus 20 equals 0. Now obviously the 15 times 0 is just 0. So 8x plus 20 is equal to 0. Take 20 away from both sides. Divide both sides by 8. And minus 20 over 8 is the same thing as minus 5 over 2. So the point P or Q, it doesn't matter which way round you write it really, is minus 5 over 2, 0. Right, what about where it crosses the other coordinate axis? Where it crosses the y-axis? Well, we know that's going to be when x equals 0. So if I now make x 0 here, I'm going to get 8 times 0 minus 15y plus 20 equals 0. And obviously the 8 times 0 is just 0. I can now subtract the 20 from both sides. Divide both sides by the minus 15. And minus 20 divided by minus 15, well, the negatives cancel out. And 20 over 15 is the same thing as 4 over 3. So we have the other coordinate. The point Q is the coordinate 0, 4 over 3. Right, now the area of this triangle. To help me visualise this, let me just draw a very quick, actually I'm not even going to use a ruler, a very quick rough sketch of what's happening here, and then hopefully it'll be easy for me to say what the area of this triangle is going to be. So the point O is here obviously. Then we've got the point minus 5 over 2, 0, so I'll put that there. And then we've got the point 0, 4/3. So I'll put that there. So here is my triangle. Here is the triangle OPQ. This is the triangle I want to work out the area of. So the area is going to be half base times height. Now, the base of this triangle is just going to be 5 over 2. The height of this triangle is just 4 over 3. So a half times 5 over 2 times 4 over 3 is going to be 20 over 12, which will simplify a little bit to be 5 over 3, and that's the area of that triangle.